Hello. What we're going to look at now is a way of identifying a little bit of behavior in the video data. Previously we were just looking at detecting things that are moving and tracking them from frame to frame through the video without really paying much attention to what was actually happening in the videos. And what we're going to start out with is what we call a little short-term action recognition. So by this, I mean actions that's sort of happening instantaneously. And I give an example of waving of a hand. Okay, it's something that sort of takes a second or a half second to do. It's not a full understanding of what's happening in the video. That would be like meeting a friend, okay, where you see a friend in a distance and you wave to them and you walk up to them and you hug or something like that. That would be a whole long sequence of these instantaneous type actions all strung together to make a kind of behavior. Well, we're not going to look at that sort of behavior. We're just going to look at the instantaneous kinds of activities. Now, there are people who do research on these longer term behavior activities, and I've done some of that myself, but that's not what we're going to talk about here today. So we're going to really think about this short-term action behavior as a kind of instantaneous sort of thing. We've got a particular video frame, and we're going to want to look at a few frames before and a few frames after, maybe 5 or 10 or 20, depending on what your frame rate is and what's the scale of the activity. But as you can imagine, like this hand wave, it takes about a second. You record video at 25 frames a second, so you might say, well, I'll take the instantaneous frame plus or minus 10 frames as a way of describing that particular action. The technique that we're going to look at is really just based on an example by the authors that I've got listed right here. And it's what you might call an appearance-based or a viewpoint-specific type technique. And what that means is that we're going to learn a model of the behavior, but that model pretty much will only depend upon looking at the same objects from exactly the same viewpoint. So if I had taught you a model of how to wave the hand this way, and then you saw a person waving their hand like this, the model wouldn't be the right model for recognizing it. You would have to learn models for different viewpoints. So we're going to only look at a technique that's only good for sort of single viewpoints, and then if you want to use multiple viewpoints, you have to learn multiple instances of them. We're also going to constrain the problem that we're going to look at a little bit. So one of the examples we're going to look at is based on this sort of football video type scene right here. And you can see here is one of the tracked players, and we want to know what's this player doing. Here's an enlargement of that player, and you can kind of get a little bit of a feeling for, you can sort of see where the body and the shorts are and maybe where the chest and the legs are and things like that. But you don't get a very good idea of exactly the shape of the person and specifically just exactly what they're doing at this very moment. And that leads us to the kind of constraint that we're looking at here. There's really 3 different areas where people do this kind of activity analysis. One is where they call the sort of the near field type analysis, where you have a good zoom on right up onto the body, sort of like what you're looking at right here, where you can actually see the individual features, the head, the mouth, the arms, the fingers, and things like that. And you can fit a geometric model to that and analyze what that body is doing very specifically. Alternatively, there's sort of like the far field, and that's where the targets you're looking at are so far away that you can't really see very much about it. You can see that there's something there, you can see that it's moving, you can maybe tell that it's not noise, but it's actually some object, but you really can't see very much. And about all you can do with that kind of data is really just watch where that target goes by tracking it, see what parts of the scene or the image that it moves around in, and from what it does there, then you can maybe estimate something about its behavior. So those are the two things that we're not going to do. The one that we are going to do is what's called this medium field. And that's where these objects are sort of about 30 pixels high or 30 pixels wide. And that's roughly the size of this object right here. So you can see a little bit of the detail, but not really enough to be able to identify which person it is, what player number they are, precisely where the heads and hands are, which of these feet is in front, that kind of thing. So that's the scale that we're going to be working with here. And what our goal is that we want to be able to take, for example, a set of video data, something like this, and extract from a database a matching set of actions that says, okay, so if I saw this bit right here, and I've got in my database, this is a certain kind of run. When I see this, then if I extract this from the database, then I can say, oh, well, that's the same kind of run that I'm looking at here. So we want to be able to label what the instantaneous activity is by matching it with things that we have stored in the database as examples of that behavior. Right, so there's an example right there that we want to be able to work with. In order to do this, we have to really compensate, well, we have to take account of two different kinds of motions. So as this football player is moving across the pitch, the player is moving against a background. But in addition to that motion, the player is also moving with respect to him or herself. So there's arms moving back and forth, and heads and legs and that sort of thing, maybe body turning. And it's that latter motion that we want to use for the analysis. The first motion is just, moving across the pitch, and it doesn't really tell us anything about what the person is actually doing other than, sort of running or walking or something like that. Whereas it's the pattern of the arms and legs that tells us a little bit more about the specific action that the person is doing. So somehow we have to separate out these two factors. Fortunately, we've already looked at a target detection and tracking type algorithm in a previous lecture set. And what that's allowed us to do is sort of identify where the moving target is in a particular frame. And for each consecutive frame, we can identify that target. So we can base our analysis on, say, the center of this bounding box around the person rather than its position on the field. And that's what we see here. These are effectively those bounding boxes for that tracked player set into just a little mosaic here, so you can sort of see how they're sort of changing over time. But in each of these, we've taken away the background motion, effectively the motion of the person against that background, and now we can just look at the motion of the person themselves. So that's going to be the key to our analysis right here, is looking at patterns of behavior, of action, relative to the target itself. And we're going to look at a way from of representing those patterns and a way of matching those patterns coming up in a future lecture. This sort of summarizes the whole process that we're going to look at right here. So we've got our input video, and we've done our target detection and tracking, and that allows us to stabilize it, as we've said before. And then that gives us some sort of a figure-centric type sequence, where we have a sequence of images where instead of the person's moving across the scene, effectively, it's like they're being in one place, and you see the action without that translation. So we start with that sequence. We use an optical flow type process to be able to look at where the motion is of that person with respect to the whole body, and that's going to give us a kind of descriptor of the action. A little bit of a complicated descriptor, but we'll go through that process. And then in order to identify the action, we need to compare that new motion descriptor with a database of previously stored motion descriptors and their labels for what kind of action. So we're going to need to have some sort of a matching type algorithm that matches these two together. And from that, we'll be able to get some labels about the action, possibly some labels about the position of different limbs, arms and legs and things like that, and possibly some information about the orientation of the person. But really, we're mostly just going to concentrate on the action labels. Right, thank you very much.